Write a balanced chemical equation for this reaction. We have chlorine plus sodium bromide gives you bromine and sodium chloride. First, write a skeleton equation. Chlorine is a diatomic molecule, so we write Cl2. Sodium has a valence of +1, bromine of -1, so that's how you write sodium bromide. Bromine, also a diatomic molecule, so it's Br2. And then sodium is +1, chlorine is -1, so there you go. That's your skeleton equation. Next, count up the number of each type of element on each side of the reaction. The reactants on the left and the products on the right. You won't have to do this every time, but for now it's a good formality to get you going. So chlorine, you have 2. Sodium, 1 bromine. On the right side, we have 2 bromines, and 1 sodium down there, and 1 chlorine. So does that look balanced? No, you have to have the same number of each element on each side. And here's where we take an art form that is balancing equations and trying to come up with some rules that make the art a little easier to do. So let's identify one element that is not balanced. It's best to start with an easy element. And by what we mean with easy element, the fewer places the element appears on both sides of a reaction, the easier it will be to balance. So let's look at this. Why are we choosing chlorine? Well, chlorine's here in one place, chlorine's over here. Sodium is over there next to bromine, and it's also next to chlorine. Bromine is next to sodium, and then it's by itself. So yeah, actually it's kind of a flip on this one, but we're going to choose chlorine. It's on the top. See how that goes. So we highlight it there, and then we move on to the next page. Identify the side that needs more of that particular element. Well, that's easy. We've got chlorine highlighted. We have 2 over here, and we have 1 here. So we circle this one. We have to do something to that chlorine on the right side. Now we can go from the table back up to our skeleton equation, and we identify which molecule or element needs an added coefficient. In this case, we're going to work with sodium chloride, salt, because that's the only product containing chlorine. To determine the coefficient, take the amount of that specific element that you need from the molecule. Okay, so we need 2, because there's 2 chlorines on the left, we need 2 on the right, and divide that by the amount of the element you have, which is only 1. So 2 divided by 1 is 2, and then put that 2 in front of the sodium chloride. If for some reason it's not a whole number, like 1.5, multiply all the formulas in the reaction by a whole number to make all the coefficients whole numbers. So if you had 1.5, multiply that by 2 to get 3. Again, this may look like a lot of work for a very simple reaction, but when you get more complex ones, it's good to have a roadmap like this to go on. Now, take a step back and see if we fixed it. So we go back to our table, and we didn't change anything on the reactant side, but now let's go over here. Still have 2 bromines, and what did we do here? We have 2 chlorines, which is what we wanted, but it also multiplied the sodium by 2. So we have 2 there. So we will go to the next slide and see how we fix that one. Just take a look at it for a second. Maybe you can figure it out before we get there. And when you're ready, advance the slide. Well, I'm hoping you saw what to do. When we multiplied this by 2, we wound up 2 chlorines, 2 sodiums, and 2 bromines. You look to the left, we have 2 chlorines, that's good, but we only had 1 sodium and 1 bromine. How can we make them 2? Well, very nicely, the sodium bromide is standing all by itself, and if we would put a 2 in front of it, see the purple 2? We now have 2 sodiums and 2 bromines. We didn't touch the chlorine, okay, so that still just has 2, but look what we have. Everything matches. This may take more than one iteration, and frequently will when you have a more complex reaction, but we now have a balanced chemical reaction.